Hello everyone, welcome back to another great section of this wonderful tutorial class. Today we are going to be looking at the topic random variables. Random variables. And please don't skip any part of this video. This topic is here to bless you. So the class is here to bless you. So don't skip any part of it and don't distract yourself by any means. Ensure you watch this video from the beginning to the end. And at the end of the day, you will be blessed. You will be blessed. So this is the Best Academy, and let's look at what we have. Random variable. What is a random variable? That's the first thing. Now, a random variable is a variable whose value is subjected to variation of choices. A random variable is a variable whose value is subjected to what? Variation of what? Of choices. Now, let x be a random variable. Let x be a random variable which corresponds to the occurrence of having one head, or to the occurrence of the numbers of heads obtained when two coins are tossed once. When two coins are tossed once. Therefore, the range space of x, is this another what we're talking about? The range space of x will be, what? Now we said x denotes the number of heads when two coins are tossed once. So then I want to check how many heads are we going to have. The sample space will be head. Okay, head C. Head, T. Now what do this way? We have 2 coins, or we are tossing one coin twice. Let's say this is the coin. Is either going to have head or T. You toss it once. You will have either head or T. So you have to toss it once. You toss it again. You have either head here or T. You have head there. You have T. So the sample space will now be head, T, head, T. So we get it from this tree method. So this one has this place now. The first our first atom is having 2 heads. Then our second atom is having 1 head. Our third atom is having 1 head. And our fourth atom is having 0 head. So the range space of x, which is the number of heads, will be we have 0 head, we have 1 head, we have 2 heads. Don't write from we have 0 head, we have 1 head for this 2. This will be the range space of x. The same way, if x denotes the number of heads when a coin is tossed 4 times, the range space of x will be 0, 1, 2, 3, 4. So I go back. The range space of x will be 0, 1, 2, 3, 4. You can try your best to write this range space out. This way. In case they're asking you, what is the probability of having 2 heads if you toss a coin 4 times? So you'll be able to get it. And you can get out from after you have written out the true experiment. So let's just try and do it. This is the coin. If you toss it once, you're going to have head or T. So you get this one, give you that head or T. This one give you head or T. This one give you head or T. Give you head or T. This one give you head or T. This one give you head or T. If you do it 4 times, head or T, head or T, head or T, head T, head T, head T, head T, head T. So I will have. So let's combine this together. We have head. First one head. This is sample space. The next one head T. Head T. Head T, head. Head T, head. Head T. Head T. Head T, head. Head T, head. You have head, have head, T, T, T. Head, head, T, T, T. You have T, head, head, head. You have T, head, head, head. You have T, head, head, T. T, head, head, T. You have T, head, T, head. You have T, head, T, head. You have T, head. You have T, head, T, T. T, head, T, T. T, head, T, T. You have T, T, head, head. You have T, T, head, head. You have T, T, head, T. T, T, head, T. You have T, 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 head. T, 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 head. You have T, 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 T. T, 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 T. That's what we have. So the number of heart conditions should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That means you are correct. You are very, very correct. So this is the sample space of this experiment of tossing a coin 4 times. So the range is going to be this. We're going to range from 0 head, which is having 0 head. 1 head, we have 1 head, we have 2 head, we have 1 and 3 heads. The highest will be 4 heads. That's what we're going to have. Now we're going to look at discrete random variable. Solving it. Discrete random variable. Discrete random variable. Now let S be a discrete random variable. Let S be a discrete random variable that can assume any value. That can assume any value, let's say S1, S2, S3, and so on, with respective probability. For example, now, let this S be a discrete random variable that can either be 0 head. Okay, this one is the number of head that be. You know what I'm trying to say, so that we just get it. Let this S, let me call this X a discrete random variable. That can, remember S denotes the number of heads here. S denotes numbers of what? Heads. Now let this S I'm talking about be a discrete random variable now that can either be 0 head, 1 head, 2 head, 3 head, 4 head. S1, S2, S3, S4, S5. S1 is 0 head, S2 head. With respective probability, the probability for 0 head. What probability of 0 head here? 1/16. That will be probability of 0 head. For example, space is 16. That 16 is atoms here. You have 16 atoms. So sample is 16. The probability of 0 head 1/16. Probability of 1 head, you can count the number of atoms that have 1 head and divide by 16. That will be probability of 1 head and so on. With respective probability, there's a P1, P2, P4, P4, P2 for that. Now, if the summation of all the probabilities together are equal to 1, that's what I'm trying to say. If we sum together, just try and get this one, I don't want to use speed English. All the probabilities of X equals to Xi. Of X equals to Xi, where this X denotes numbers of heads, and this Xi, this I can either be from 0, 1, 2, 3, 4, and either be 0 head. This one is at S equal to 1 head, S equal to 2 head, S equal to 3 head, equal to 0 head. That's why I'm putting I there. That I can either be 0 head, 1 head, 2 head, 3 head, and so on. If we sum up all the probability of 1, 2, 3, 4, 5, and they are equal to 1, therefore we say that S is a discrete random variable. S is a discrete random variable, and this is our probability mass function for that discrete random variable. That discrete random variable. We will sum up all their probabilities together, and they are equal to 1. The summation of all the probabilities together is giving you 1. Therefore, we say that this is a discrete random variable. Now, what about a continuous random variable? What about continuous random variable? Now, we have discrete random variable, we have continuous random variable. Now, for continuous random variable, if we say a continuous random variable is a variable that is between intervals, that is in the range of 2 intervals. It's not actually, you are not actually summing using this sigma notation. Another summing probabilities is your probability of some values between two intervals that is either finite or infinite, or free numbers. Two intervals of free numbers that's either finite or infinite. And if you sum up, if you take the integral between those intervals of these variables we are talking about and is equal to 1, we call it a continuous random variable. Now, for continuous random variable, we say if the range of a random variable x, that is contained in an interval that is either finite or infinite or free numbers. Therefore, we say x is a random variable if the integral of that function of x dx is equal to 1 between intervals a to b. For a be less than x, s will be less than b. S is between these two intervals a and b. So if the integration of this function of x we're talking about dx is equal to 1, then we'll say this x is a continuous random variable. So what? It's a continuous random variable. For this, we're talking about dealing with interval, but for discrete, we just sum up all their probabilities. And if it's equal to 1, we'll say it's a discrete random variable. Now, let's quickly look at a very simple question. We can try this one to check that it's a discrete random variable. Find probability of this, sum everything together. And we show that it's a discrete random variable. Now, let's have some questions now to see what we are going to have. We'll look at expectation of a random variable. A discrete random variable has a probability mass function as function of x equals to a bracket 2x minus 1. A bracket 2x minus 1. For x equal to 1, 2, 3, 4. S equals to 1, 2, 3, 4. Obtain the value of A. Solution. We said for this random variable, the summation of this function of x will be equal to 1. For probability of x is equal to s will be equal to 1. So the summation of this A, the summation of this A bracket 2x minus 1 will be equal to 1. So what I'm going to have A outside. For put 1, we have 2 times 1 minus 1 plus put s at second one, which is 2. 2 times 2 minus 1 plus 2 times 3 minus 1 plus 2 times 4 minus 1, and everything will equal to 1. For this one to be a discrete rule. We sum up everything here together. S equal to 1, 2, 3, 4. I already said that before when I was explaining. S must be y, 2, 3, 4, and so on. So everything will become 1. So I'm going to have a bracket. We have 2 times 1, so I have 1 plus 3 plus 4. Right? We have 1 here. We have 3 here. We have 2 times 3, we have 5. That's 5 plus 5. And the other one is plus 7 plus 1. So we have a bracket. This plus this, that's 4. 9 plus 7. 9 plus 7. We have 16. Equals to 1. So we will have 16a is equals to 1. We have that by 16. Then a will be equal to 1 over 16. That will be the value of a. That will be the value of a. So for this one to be a discrete random variable. So let's look at this other question. A continuous random variable has the PDF. Now, discrete random variable has to do with PMF, which is probability mass function, and continuous random variable has to do with PDF, which is probability density function. So a continuous random variable has the PMF, function of x equal to c bracket 1 plus s squared. Is the PMF. Probability density and PDF. for this density function of this continuous random variable. A continuous random variable has this probability density function. Within the range, 0 is less than x, is less than 1. Within the range, 0 is less than x, x is less than 1. Obtain the value of c. Obtain the value of c. I already told you, if you integrate this f of x dx will be equal to 1 for this random variable to be a continuous random variable. So let's put the range we have from 0 to 1. The first one of x is what? C bracket 1 plus what? S squared dx. And this one will be equal to 1. So this will be a valid PDF. It will be equal to 1. Valid PDF will be equal to 1. So let's integrate now to see what we're going to have. Let's integrate to see what we're going to have. So we're going to have C bracket. Now integrate 1. Let's look at integrate. Now this one don't have this x. So anything I don't have this x, you want to integrate it, just use it to multiply the x for polynomial functions only. Polynomial functions only. You know this times x, so it's going to be 1x. That's what we're going to integrate that. Then plus, if you integrate this, or you can say the s is equal to 0. Add 1 to 0 and divide that by 1 plus 0, that will be s over 1. You see the x. So that's just a shortcut. 1 times s give us x. Now don't say this one times this, so no. This one is only, you only do it like that if it's a constant number without x. That's why you do it that way. Then for this one, I'm going to integrate this one s squared. What you integrate that s squared, what you do, you will add 1 to the power and divide by that same power. That's how to integrate that to that one. We see everything will now equal to 0. From range of 1 to 0. If everything will be equal to 1. Everything will be equal to 1 for this one to be a valid PDF. Going to be a valid PDF. Everything will be equal to 1. Then let's go. So the next thing you do, therefore obtain, put the upper side of your limit. So therefore put the upper limit. You have place 1 here. Then we are seeing this. Or let's simplify everything. S cubed over 3 from 1 to 0 is equal to 1. We will have, so if I put this upper limit, then we are seeing that will be 1 plus 1 cubed over 3. Then minus, we put the lower limit again, 0 plus 0 cubed over 3. This is how to do this. This is called definite integration. Call this one definite integration. So after you have integrated it, place the upper limit in where you have the variable. Then minus, place the upper limit where you have the variable, minus, place the lower limit again. So that's how to do. This one equal to 1. We have C bracket 1 plus, we have 1 plus 1 over 3. Then minus 0 plus 1. Everything here will be 0. We have C bracket, we have 3. That is 3 plus 1. Okay, 1, that is C bracket 4. 4 over 3 plus 1. Sometimes this we have 4C. Equals to 3 times 1, we have 3. That was by 4. 4. Then, so I'm answering this, our C will equal to 4 over 3. So I don't have. So for this one to be a valid PDF, our C will be equal to 4 over 3. That's what I don't have. Now, let's look at expectation of a random variable, or expectation of x. If x is a random variable, what is the expectation of x? Now, expectation of a random variable. Expectation of a random variable. Now, if x denotes a random variable, then the mean or the expectation of x, we also call it sometimes the mean of a random variable. Therefore, the expectation of x, this will be equal to summation of for all x times probability of x equal to x for discrete random variables, and this for continuous random variable. Remember, it's just happening here. And if x is a random variable, the expectation of this x will be for discrete. Don't use x to multiply the first one I gave you for discrete random variable. Then use x to multiply the one I gave you for continuous random variable. This one is for continuous. while this other one is for discrete. So this is for discrete random variable, this is for continuous random variable. You multiply them with s. If they are asking you to look for expectation of x. So what you have to do, follow the same way, but multiply it with x. If they say what is the definition of s squared, multiply with s squared. Let's run with s squared. I'll show you how to do it. Let's just look at this. Let's look at this to see what we're going to have. Now, let's look at this following few properties of expectation of x. Properties of expectation of x. Now, number one, expectation of a constant times x is equal to that constant times the expectation of x. Note, the expectation of a constant is always equal to that constant. For example, the expectation of 5 is equal to 5. Now, the expectation of s plus a constant is equal to the expectation of s plus that constant. All the things of that is very, very important. So, if I can solve this question now, which is the following, for the following discrete distribution, which is this, find the relation of s, relation of s minus 1, relation of 3 bracket s minus 1. Before you can solve this problem, you must understand these three properties. We have other properties we also look at. I want to just use these three. That's why I'm just looking at these three. So, number one, what will be the expectation of x? That's the first thing. Now, the expectation of x, this one is a discrete random variable. Or say the expectation of x for a discrete random variable is equal to the summation of x times what? Probability of what? X equal to x. Probability of what? X equal to x. Probability of x equal to x. Already here. Like the respective probabilities. So we're going to sum this one together. But we're going to use to multiply x, which is x, not x here. So the relation of x now will be, for the first one, we use to multiply this s times this one. For the first one, s times this one, we're going to have 1 times 0.01, 0.0, that's 0.1, plus, for the second one, this times this, 3 times 0.4, plus, let's do this times this, 5 times 0.3, for the third one, plus 8 times 0.15, plus 9 times 0.05. So if you do this very well, you're going to have 4.45 as the expectation of x. That's what we have. The expectation of x. Then it's already done dealt with. So look at this other one. What will be the expectation? What will be the expectation of x minus 1? The expectation of x plus 6. You know the expectation of x plus that c. So say it. So this will also be expectation of x minus 1. But that constant will be the same. This one is constant. This one is constant. Constant with 1, 2, 3, 4, 5, 6, all those numbers. So now I'm doing it this way. This one is like the division of s minus c, because the division of s minus that c. Then for we will have the division of s is already 4.45 minus 1. That gives 3.45. That's what I will have. That's what I will have. Then number the next one, the division of 3 bracket s minus 1. Then the next one will be the last one, the division of 3 bracket s minus 1. This will be the same thing as the division of 3 times s, let's say 3, x, 3 times 1, let's say 3. Or you can just move out, you can also say this one is the same thing as, okay, let us do that one. 3x minus 3. And this one will be the division of 3x minus just 3. The division of 3x minus 3, because this one will be affected by the division of x because it constant number. This one will be the division of 3x, the division of 3x, instead of cs is c expectation of x. This one will be 3 expectation of x minus 3. This one will be, you must have to do this, is very, very important. That will be 3 times 4.45 minus 3. So this one times this minus this will give us 10.35. That's what I'm going to have. That's what I'm going to have. So that is the answer to that question. Now look at this one. For the continuous distribution in PDF, f of x equals to 1 minus x over 2. For x, 0 is less than or equal to x and x is less than or equal to 2. Find the expectation of x. Find the expectation of x. The expectation of x for this question, you do it very well because you are going to do it yourself. To be equal to 2 over t. Go and solve it out. The expectation of x here will be integral from 0 to 2 of x multiplying that portion of x. And what is the portion of x? What is the portion of x? 1 minus x over 2 is x. So the solution now to go have this. So go and try and solve it. See if we can have the answer. That will be the expression of x. So quickly, let's look at variance of the random variable. That is variance of x. Variance of x.
Now, variance of a random variable. Variance of a random variable. Now, we do obtain variance from expectation of x. We do obtain variance from expectation of x. Now, recall that the expectation of x is the mean of a random variable. We have already explained that a few minutes ago. And if you want to obtain the variance of this random variable now, the variance is divided by x equal to expectation of x squared minus expectation of x raised to power 2. So I'm going to do different this and this. We are answering this question. Now, the standard deviation is simple. That and the standard deviation is not the square root of variance. I don't think of that. Very, very important. So the following are the quantities of variance of x. If x and y are independent variable, then by x plus by y we go to var of x plus var of y. That's variance of x plus variance of y. While variance of the constant times x is equal to that constant squared and variance of x. The variance of x plus the constant is equal to variance of x. Why? Because the variance of the constant is equal to 0. Take note of that. It's very, very important. Now, let's look at this question. From the below table, I can tell here. And this one is a discrete distribution. I'm going to take this table as a discrete distribution. You know that. Find the dimension of x, variance of x, variance of 4x, and variance of x plus 5. That's what I'm going to look at now. Division of x, variance of x, variance of 4x, and variance of x plus 5. So what is the division of x? That's the first one here. Division of x will be summation of x times what? That probability of x. Remember that for discrete distribution. Use that to multiply probability of x. I'm going to have s is 8. So I'm going to do this way. I'm going to be having. Let's see what I'm going to have. Take s, take probability of s. S times probability of s. This one is s, this one is probability of s. That is 8 times 1 over 8. And go to this. Plus, what is the multiplication? You add in plus 12 times 3 over 16 plus 16 times 3 over 8 plus 20 times 3 over 16 plus 24 times 1 over 8. So this one is going to give us, if you cancel it, you have 1 plus 4, 3. 3 times 3 is 9 over 4 plus 8 here, 1, 8 here, 2. That's plus 6. Okay, let's check what can go. 4 here, 4 here, 5. That's 15 over 4, 15 over 4. Plus 8 here, 1, 8 here, 4. Plus 4. Yeah, plus 4. Plus 4. So you have anything here, you're going to have 16. So you're going to have the division of x. Now, what about the division of x squared? Because we need the division of x, this is the division of x. We need the division of x squared. One will have variance. So let's do this to see what we're going to have. So the division of x squared means use something like this. S squared times probability of x. That is mean. Because as we're using s to multiply probability of s. The division of x squared use s squared to multiply. That is the difference between the two. That is difference. So this is what we are going to have. So let's start. So we square this x, this multiply. We use it multiply. So let's go to square it. Multiply. The same thing, do the same thing. Then square this. Multiply to this. Then square this. Multiply to this. Then let's square this, divide this, by 3 over 16, square this, try to 1 by 8. Everything I will give you, if you solve that very well, you are going to have 278 more than 78. So you have. So your ES, the of S square, the of S square will be 278. Then if our X will be the region of S square minus the region of X square. I will show you how to use this one. The region of S square will be 278 minus the region of X was 16. You square it. That will give you 42. So then, for the next one, which is var of 4x, it should be, remember, var of AX will be A square var x. So it was 4 square var x. So this is very well. We have 4 square times 22. This will give you 352. So I go up 352. So I go up. Then the last one is var of x plus 5. So it will be var x plus var 5, which is var x plus 0, which is var x is 22. Because var 5, var of the constant is equal to 0. So ensure you go through this class over and over again. Both try your hands in other questions, both continuous and discrete distributions. See you guys in our next class. God bless you. Thank you.